Hey fifth graders, room 10, here we go. Hey, we're jumping into science right now. I want you guys to open up to page 112. I'm going to roll through and tell you basically all the terms and definitions that you're going to need to know for tomorrow's test. All right, I mean basically you can look through the whole chapter, chapter 5, and if it's a bold word, you're probably going to want to know that thing. So remember, first off, one of those things we need to know is the atmosphere. Remember, that's that thin blanket of gases that helps protect the Earth from the rays of the sun. Remember, it's super thin. It's all kinds of dust particles, crazy stuff up there. So, atmosphere, number one, that's one of those things you need to know. Now, you also need to know what air is. A mixture of gases. Pretty simple, right? Now, remember, the weight of the air that is pushing down on us, that is air pressure, right? Remember, whenever you are putting air pressure in the tire of a car or a bicycle, it reads that, tells you how much is in there, 40 pounds, 35 pounds, something along those lines. Now, when you go up to the mountains, we talked about this, how altitude is your distance above sea level. So sea level would be like 0, right? And then you go up to Big Bear and it's 7,600 feet or whatever it is. You're 7,600 feet above the surface of the Earth, like down where the ocean is. So you need to know that. You need to know what altitude is. On that same page, page 113, you see a picture there of a barometer. You got to remember that that is an instrument that measures the weight of the air, the air pressure. So, barometer is an instrument used to measure air pressure. Now, we talked about all kinds of reasons why that's important, because it has to do with storms, low pressure fronts, high pressure fronts, all those kinds of things. So you'll need to know that. It'll be on your test tomorrow. So, let's turn the page to page 114. So looking on page 114, one of those things you need to know is the troposphere. Remember, that's the first layer of the atmosphere as you leave the Earth. You're going up into the troposphere. Who remembers what happens in the troposphere? Do you guys remember? Weather. Weather happens in the troposphere. And now remember, Mount Everest, it told us, like 29,000 feet, only goes like halfway into the troposphere. Cool, cool, cool. All right, look at page 115 up at the top. We got the word weather. Now remember, weather is just the condition of the atmosphere at any moment in time. So when I look outside right now, I can see it's kind of breezy, 4 or 5 miles an hour worth of wind going on. It's warm, it's 80 degrees outside. It's gonna get hot this week. I saw it's supposed to be like 98 or 100, something crazy. Cool, I think that is the only only thing we need to know on page 115. Let's go ahead and turn the page. All right, page 116, we got that moving air. Remember what that's called? Bingo, wind. So you gotta know what wind is. Easy, right? Now, there were a few types of things we talked about. We talked about air masses. Now, the tricky thing with the air mass, sometimes people get the air masses mixed up with the fronts when you're looking at definitions, true or false, stuff like that are matching. So, be very careful. Make sure you know the difference between these things. Now, an air mass is a large body of air that has the same temperature and moisture. So it's cool and it's moist. Okay, that's a cold air mass. That's simple. So it's got the same temperature and moisture in air mass. All right, and we can turn the page. Page 118. Here we go. Look at that. We're already cranking through this thing. Now, on page 118, we talk about fronts. We got cold fronts, warm fronts, stationary fronts, all kinds of fronts. Really, you only need to know what the definition of front is. You don't need to know the difference between the different types of fronts. You just need to know it's when two unlike air masses meet, it creates a front of some sort. Either a cold front, warm front, stationary front. Cool, so two unlike air masses meeting up together is a front. Now, think about it. Air mass wouldn't make sense as the answer to that problem because air mass is in the sentence itself, right? In the definition itself. So it's saying two unlike air masses. You wouldn't say the answer is air masses. That doesn't make sense, right? Right? Uh-huh. Yeah, so it's a front. Cool, look at page 119. Now we're talking about global winds. Listen to that first word. I know it's a tricky one. Global. So that means those are the winds that are going around the certain belts, like around the same shapes, all the way around the earth in different directions. Woo, woo, woo. So, I mean, you can look at the definition of that, and it talks about the winds going around the earth. You know, so don't get tricked up with local winds, because that's local. We're talking global, the entire earth. Cool. All right, good. Hope you'll get it right. Now, page 120. Check out page 120 with me. Page 120, we got local winds. Now, remember, the local winds, kind of like the Santa Ana winds we have sometimes, like in the springtime or in the summertime, where, you know, the heat's rising, then all of a sudden the winds come blowing through it all crazy, and then that's when wildfires happen. And then with the wildfires, you know, they're trying to put out the fires, the winds are blowing them, making them move even faster. Yeah, those are local winds. Those wouldn't be global. They're influenced by the temperature changes in a small area. Local. Global, the whole earth. Local, like small area. Cool, got it, get it, good. All right, so local winds, good. Ooh, you need to know what a wind vane is. Remember, the wind vane's like that chicken on top of the barn, that metal chicken that the air blows it, and it shows the direction the air is blowing. That's the job of a wind vane. Now remember, the anemometer is like a speedometer, but for the wind. It tells us how fast that wind is blowing. Like the picture in the book's got the little cups on it, so they spin around like a little propeller, and it says how fast that wind is going. Might need to know both those. They're not bold, but I told you about them because they're important. All right. Let's turn a couple pages to page 124, talking about moisture that is in the air. Now, we're going to start off talking about precipitation. Remember, precipitation is any kind of water in the air, like up in the sky, that falls to the earth. Like, whee! Now, super easy. Remember, first off, raindrops. Raindrops fall to the earth, so rain would be a type of precipitation. So remember, the water droplets join together up in the clouds, and then eventually they get heavy enough to the point where they fall as rain. Voila. All right, cool. Now let's talk about freezing rain. Now with freezing rain, the raindrops fall as rain, whee! But when it hits the earth, like down at the earth level where we're at right here, it's below freezing. So when that rain hits that car in the driveway, that's, 10 degrees, when the rain hits that thing, that rain freezes on the car. That's why it's called freezing rain, because it falls as rain, but then it freezes. Now, when we're talking about sleet falls as rain. Here it comes. Whee! But then the air right here is frozen. Maybe the air down here at the earth is not frozen. It's like 40 degrees. But there's like a 25-degree drop, or 25 degrees right here in the middle of the atmosphere as the rain's falling. So it's rain. Whee! Brr! It freezes and then falls as tiny little ice pellets. Cool. So that's freezing rain. Let me jump to... Wait, that was sleet. I just said freezing rain and sleet. Sleet falls through the air and then freezes and falls to the earth as little ice pellets. I got mixed up there at the end. Okay, cool. All right, snow. Snow is ice crystals up in the clouds, and they join together, and then eventually, once they get heavy enough and gravity pulls them down, they fall to the earth as snow. And it must be freezing up there. It must be freezing down here. Otherwise, it melts in the air as it comes down, ends up just being kind of like sleet, rain-ish, snow stuff. Cool. Another big one. This one gets a lot of people on the test. Hail. Now, hail does not fall during cold weather. I mean, it's a possibility, but most likely thunderstorms that produce hail usually fall during warm weather, because you have a cold front coming down from Canada and you got a warm front coming up from the Gulf of Mexico, and when those two meet, boom, thunderstorms. Now, it creates thunderstorms. It does not always create tornadoes, not always, but it will create thunderstorms. Now, in those thunderstorms, there's a lot of updraft winds, and remember, those winds grab that rain and they push it so high in the atmosphere that the water freezes, and then it comes back through the clouds, and the wind's still pushing it back up, so it freezes again, and it gets bigger and bigger and bigger, and then finally the hail, once it's heavy enough and the wind isn't strong enough to push it up there anymore, it falls as hail. But it's usually like 98% in warmer weather. It doesn't happen when it's cold outside. That would just be snow, or freezing rain or sleet, one of those things happening. Not hail though, normally in warmer weather. Sweet. Page 126, go ahead and turn the page with me. Page 126. Ooh, now we're going to talk about things that are not precipitation, like dew and frost. Dew and frost, that's outside. There was dew outside before I went to bed last night. Did it fall from the atmosphere? No, it didn't. It was already in the air, and then once the temperature got cool enough, it turned to moisture. Like, it turned to actual wetness, water droplets all over my cars parked outside. So that's why my cars are all dirty all the time, because it's like, why wash them? They're just going to get dew on it the next night, because there's no room to park it with all my weightlifting stuff in here. Oh well. All right. Now, humidity is water vapor in the air. So right now it might be, it's kind of muggy outside today, even though it's like only 80. It's kind of like, ugh, like sweaty, like, ugh. So, that water vapor, that humidity in the air is probably like 65, 70% right now. Page 127, boy, we're cranking through this thing. You guys go through, you look through your book, you check out the things I'm talking to you guys about. You're going to do great on this test, I promise. Now we're talking about clouds. And remember, clouds are formed from condensed water vapor or ice crystals up in the sky. Now, there's 3 types of clouds you're going to have to know. And I'm putting pictures of each type of cloud in your test, and you have to say, that's a cumulus cloud, or that's a stratus cloud, or that's a cirrus cloud. So let's look at each one and see what they talk about. Like, what are the descriptions that go with each cloud? Stratus clouds. They're usually flat, like blankets, and they're usually the lowest clouds in the atmosphere. So normally it's just kind of like one long, big, huge cloud. And you can see a picture on the next page, on page 128 and 129. Now, cumulus clouds are like the big, fluffy, cotton ball looking clouds, just like boom, 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 all over there in the sky. And remember, those cumulus clouds are the ones that can turn into thunderstorms sometime. And then, when they're producing precipitation, they're cumulonimbus clouds. But yeah, I don't think you need to know cumulonimbus, just cumulus. Good. All right. Cirrus clouds are the ones that are super high, and they're thin, and they're wispy, and they're kind of like, woo, like up way high in the atmosphere. Those ones, let's see. Yes, it says Cirrus clouds are made usually of ice crystals more so than water droplets, because they're so high up there, they're like little ice crystals. Isn't that cool? Sweet. And then you can see all those pictures on page 128. They have little drawings of them, and then they have actual pictures of them. The actual pictures will be what's on your test, though, so make sure you pay close attention to that. All right, page 130, my favorite section. Ooh, excuse me. My favorite section of this whole chapter is talking about severe weather. So you need to know what a tornado is. You need to know about lightning and thunder. You need to know that a thunderstorm occurs when a large, swift-moving warm air mass meets a cold air mass. Oh, I got the hiccups. Look at that. So those things will be on your test, along with, let's see, hurricanes. Now, hurricane is a storm with strong spinning winds, but where do they form? Do they form over land or out over the ocean? Yeah, out over the ocean. That might get some of you guys. I think it's a true false, or maybe it's a matching one or something like that. You got to be careful. Some of you might have missed it on Friday's quiz because it gets people all the time because you read it so fast. You're just like, ooh, strong, swift, twisting winds. Yeah, it's a tornado. Yeah, you got to look and see where it says where it's formed at. If it's formed over land, awesome. That's going to be a tornado. If it's formed out over the water, 99.9% of the time, that's going to be a hurricane. Cool? All right, wonderful. Let's see, I don't think there's anything about blizzards and heat waves, so we can go ahead and turn the page to page 132. Now, weather warnings, ooh, sugar's going up. Remember, with the weather watch, you guys, we are watching for weather, but it's not actually happening yet. With the weather warning, the storm has started and we are trying to warn you it is time to get in your basement because it is danger time. Okay, just want to make sure you knew the difference between those because that will be on your test. You'll have to tell the difference between which is which. Cool. Turn the page again to page 135, talking about weather forecasting. You're going to have to know what those people are called that forecast the weather. It's not very hard. They're meteorologists. Think about meteors being up in the sky. They are studying the sky and the weather patterns and the global winds and the local winds and satellites and doing all that stuff. So, meteorologist. Cool? Now, a weather forecast is just a prediction of future weather. So like seeing that this week we're going to have 98, 97 degree temperatures, they've looked at satellite images in cold fronts and warm fronts moving through, several days away from our space right here where we're at in California, and they can tell that in several days that hot air is going to be here and it's going to be toasty. Right? It's kind of cool that they can do that. So they can do that all the way out, usually like 14, 15 days, and it can be relatively accurate where they can get it pretty close. All right, and I think that was the end of our chapter. Awesome. So study those things, look over your books, check out all those bold words. Remember, tomorrow's test is not open book. Your quiz on Friday was, but this one's not. So make sure you put your books away, you put any notes away, and hey, I might not be watching you with my eyes, but God's watching you. He knows what's up. Make sure that you're not asking parents for help because, hey, they're not in this class. So you should be taking this test by yourself. I know some of y'all taking this test by yourself, some of those grades, kind of rough. But man, study. I know you guys can do well, but you have to apply yourself. You have to actually try. If you don't try, it's not going to end well. You know what I'm saying? All right, cool. I'll see you tomorrow for your test.